This is our third lesson of the week, and you can see all the shapes of the quadrilateral. It's not a repeat of the same lesson, it's just that now we're looking at the diagonals and the angles a little bit more inside the quadrilateral. So we're adding some information, and it's actually grade 8 stuff. I don't think we're adding anything here. So first of all, what's the diagonal? So this is a parallelogram, okay? Very important you remember the names, parallelogram. So diagonals are basically the two lines that connect the opposite vertices. These are the vertices. Okay? Right, now what can we say about the diagonals in a parallelogram? They bisect each other. Okay? Let's write that word, bisect. Okay? That's a word we're going to use a lot today. So bisect means split in half. Okay? So you can see these two diagonals, they're not equal to each other. This you can see is shorter than that, but this is equal to that, and that is equal to that. So the diagonals bisect each other. Okay? Right. Moving on to, do you remember what you call that? Okay, it's a parallelogram that's made equal, so it's like a perfect parallelogram. That's called a rhombus. Okay? Now, of course, the diagonals bisect each other, just like, because every rhombus is a parallelogram, so the diagonals bisect each other. This is equal to that, that is equal to that, but more than that, okay, the diagonals right now are also in right angle to each other, okay? I drew it a little bit small, but this angle here is 90 degrees. The diagonals are in right angle to each other. Now, I should have said in the beginning, everything I write here is on page 149. And I really would like you to have a look at these pictures in page 149. And I'm going to ask you for the homework to write that down into your book. I know it's quite a lot, but I think by writing, you have a better chance to kind of internalize it. Okay. Now, so that's about diagonals. But the diagonals bisect not just each other, they also bisect the angles themselves, the interior angles. These are the angles of the rhombus. And you can see that these diagonals halve the angles. So this is equal to that, that is equal to that, that is equal to that, that is equal to that. So the diagonals not just bisect each other, they also bisect the angles. Now, I haven't been saying it for the parallelogram, but it's true for all of them, really. If you add up, and I didn't mention it before, but it's very important. If you add up all the angles, the interior angles of a quadrilateral, it doesn't matter, every one of those. If you add up all the angles together, you get to 360. You get to 360. Okay? At the end, well, let's just do it now. Let's just do it now, otherwise I'll forget. So let's take any kind of quadrilateral. Even not one of those, just a skew one, not a very nice one. What I'm saying is that all these angles, giving them a little different shapes, different kind of symbols, so you can see they're not the same. If I add them all up, they're all equal to 360. Why is that? How do I know that? You don't need to know, but I'm just thinking like it's quite cool. Why do we know that the angles, interior angles of a quadrilateral always 360? Well, what you're going to do is connect two opposite vertices. Okay? And then what do you get? What are these two? These are two triangles, right? Now, if I'm adding this angle and that, I'll get 180. If I'm adding that, and that, I'll get another 180. So if you add up all the angles together, which are the interior angles in the quadrilateral, you get 180 plus 180, 360. So, a bit of extra you got here. Let's move back to our next shape, which is a rectangle. Rectangle, which we said is like a parallelogram that have been straightened up. Okay? The only difference is that, yes, the diagonals still bisect each other, but now they're all equal to each other. So this is equal to that, which is equal to that, which is equal to that. Okay? And that kind of makes sense because we know the diagonals already before. We don't know, sorry. I'm saying now the diagonals themselves are equal. Okay? And if they bisect each other, then all halves are equal. Let's move on to a square. Okay? A square is like a perfect rectangle. It means that all the sides are equal. So again, all the diagonals will be the same. All the half diagonals will be the same. But just like in a rhombus, the diagonals don't just bisect each other, they bisect the angles of the square. And we know that the angles of the square, just like a rectangle, are 90 degrees. And if they bisect that 90 degrees, that means that each bit here is 45. So this is 45, this is 45, 45, 45, 45, 45. Okay, so that's that extra. Okay, all these angles are bisected into 45 degrees. Here, the angles are not bisected. Just like in a parallelogram, they're not bisected. The angles are not split into half. Okay? In the rhombus and in a square, the angles are half. Moving on to trapezium, the diagonals are not equal. They're not bisecting each other. The only thing that is equal here, if you want to look at, is this angle to that angle and this angle to that angle. Now, why are they equal? Because they are alternating angles. These two lines are parallel. That's the definition of a trapezium, just one pair of parallel lines. And therefore, these angles are equal. I mean, this equal to that and that equal to that. Alternating. Moving on to a kite. Okay, kite is kind of in its own thing. So, the two diagonals are 90 degrees to each other. So if you're building a kite, you often build these two. Okay, the guys here, when you were in lockdown, the guys living here were building kites. Beautiful kites. From sticks, from bin bags, and from just string. Unbelievable. Very good kites they built. And these two sticks will be your diagonals. And they're 90 degrees to each other. The other thing is they don't bisect each other. This side is not equal to that side, but this diagonal gets bisected. So this bit is equal to that bit. The other thing there is equal to each other. This diagonal, it splits. It's bisect this diagonal, but it also bisect the angle. So this is equal to that, and that equal to that. Okay? Right. So for work, for this lesson, I want you to actually just copy all these shapes with the information, trying to memorize it. Next lesson, we're going to solve some problems. See you there.